Hello and good morning. Let's start with another problem in continuous with the DP series. So the problem is find the longest valid obstacle course at each position. So you want to find some suitable courses. You are given zero index integer array obstacles of length n. Where obstacle I describe the height of ith obstacle. For each index I between 0 to n minus 1 inclusive, find the length of longest obstacle course in obstacles such that. Okay, so you choose any number of obstacle between 0 and I inclusive, and you must include ith obstacle in the course. Okay, you must put the chosen obstacle in the same order as they appear in obstacles. Okay, each obstacle except the first is taller than or same height as the obstacle immediately before it. Return answer of length n, where answer I is the length of the longest obstacle for index I as described above. Okay, number of obstacle between 0 and inclusive. Okay, so we are given an array having index 0 to n minus 1. So you need to choose some indexes from for each index I. Between we can need to calculate answer for each index I, and we need to choose some indexes between 0 and I. Okay, you must include I. Okay, and at last we need to choose ith index, and before it we can choose some indexes. Okay, you must put some choose, and we need to choose index in the order given in the array. That is, first we need to choose 0, then some index 3, and then index 5. We need to choose in increasing order, and at last we need to choose I. And the condition uh, what we need to certify while choosing is in order, the value next need to be of same height or it's need to be higher. So we need to choose some subsequence in the increasing or at same order, same height, and at last we need to choose I. And we need to calculate this. We need to find the longest length, and we need to calculate this for each I index. So now let's move to the sample test case. So we are given this values as 1 2 1 3 2, and index is 0 1 2 3 4. Now for first index the answer is going to be 1, as this is the only index we can choose and there is no value before it. For index 2 we can choose first 0 index, then 1 index, and these values are increasing as first value is 1 and second value is 2. So we get this is the value to choose, and we need to find maximum length as these are only 2 index domains, so answer is 2. Now next move to the index 2, that is 3. For 3 we can choose this 3, and before this 2 as this value is lesser than 3, and before 2 we can choose this one. So our length is going to be 3. For 2 we can choose this 2. 3 can't be chosen as this value is greater than, and before 2 we can choose this 2 as this value is lesser than equal to, and before 2 we can choose this one as this is lesser than equal to 2. So for this length is going to be 3. So problem is that for each index I we need to find all the values before it having value lesser than equal to. For each index I, find max length subsequence having value lesser than equal to after it. Okay, so this is the problem. Now next move to the second sample test case. So first answer is going to be 1 because there is no value before this and we can only choose this value in the subsequence. Now next move the second index. For second index we can choose this as at last we need to choose the ith index, so we need to choose this and choose index second 0th index having value 2 as this value is less than equal to the this one, so we can choose this. So now answer is going to be 2 as there are only two values. Now for that one we can choose this last one, and before this there is no value lesser than 1, so we can't choose any value. So for this the maximum subsequence we can achieve is of length 1. Okay, now move to the next sample test case. For the first one, as this is the only value we can choose, there is no value before this, so for this answer is going to be 1. Now move to the next test case. This there is a value 1 and before this there is no value we can choose having value lesser than 1, so maximum length subsequence we can achieve is of length 1. Now move to the next. So the last value is 5. We need to find value lesser than 5 before it, as there is 1 and 3 having value lesser than this. If we choose 1, then we can't choose 3. So, and else if we choose 3, there is no value before it. So maximum length what we can achieve is 2. And, the we can choose 3, 5, 1 or 5 or 3 or 5. Next move to 6. For 6 we can choose 5, then before 5 we can choose 1, or before 5 we can choose 3, so maximum length we can achieve is 3. Else if we choose 6 and 1, and before 1 we can't choose anything, so length maximum we can achieve is 2, which is lesser than what we are able to achieve, that is 3. So maximum we can achieve in this case is 6, 5, and choose one of 3 or 2. One, suppose we choose 1, then maximum length we can achieve is 3. Now let's find answer for next index, that is 4. At last we need to choose 4, and before this we need to find the value lesser than 4, that is 4 less than 1. And 1 before 1 we can't choose any value, so maximum length we can achieve is 2. And we can choose 1 or 3, and whatever we choose maximum we can achieve is 2. Now move to the second index 2, and we need to find any value before this having length value lesser than 2, and 4 is not lesser than 2, 6 is not, 5 is not, 1. So 1 is the only value lesser than or equal to 2, so maximum length we can achieve is 2. So this is the final array we need to return. 1 1 2 3 2. So now next move to the idea. So how we are going to solve. So brute force. So solution one is that if we want to calculate answer for j, we need to go to all the index between 0 to j minus 1 and check whether a of I is lesser than a of j. If this is the case and we have already calculated answer for I, and then answer of j is going to be answer of I plus 1, because for a of I is going to be lesser than a or equal to a of j, as we have already checked this in first condition. And before this, whatever length we are able to achieve, maximum able to achieve is going to be having value lesser than equal to a of I, and at last we will add a of j. So this is going to be answer of I plus 1. and for all I between 0 to j minus 1 we need to take max. So this is the idea we want to go. Let's see this on some temple test case. Okay, for index 0 there is no I lesser than 0 which we can check. So for this answer is going to be 1. For index 1 we go all the index before this, that is 0, as 0 index value, that is 3, is not lesser than 1, so we can't update this value with this, so answer is going to be 1. For 5 we need to check 1 is lesser than this, so the answer is going to be answer of index 1, that is 1 plus 1, that is 2. Now next move to the index 0. 0 index is lesser, value 3 is lesser than 5. So answer is going to answer of index 0 plus 1, that is 2. As answer is already 2, we do not need to update it. Now move to the index 3. Index 3. Okay, it's already 2. Okay, index 3, the value is 6. And we need to move to all the index before it. So at 2 values 5 is it is lesser than 6. The answer is going to be answer of index 2 plus 1, that is 3. As now move to the index 1. As 1 is lesser than 6, answer is going to answer of index 1, that is 1 plus 1, that is 2. As answer is already 3, it is more than 2, we do not need to update. Now move to index 0. As value 3 is lesser than 6, answer is going to answer of index 0 plus 1, that is 1 plus 1, that is 2. As 2 is lesser than 3, we do not need to update it. Now move to the next index, that is index 4. And now we need to move to all the index before it and need to update the answer of index 4. As value 6 is greater than 4, we cannot update the answer. Now move to the index 2. At index 5 is value 5 is greater than 4, we cannot update it. Now move to the next one, that is value 1. 1 is less than or equal to 4, we can update the answer. Answer is going to be answer of index 1, that is 1 plus 1. Its value is going to be 2. Now move to the next index 0 at values 3, which is lesser than equal to 4. So answer is going to answer of index 0 plus 1, that is 1 plus 1, that is 2, as already achieved. Now move to the index 5. Okay. Index 5 having value 2. Now we move to all the index before this and check if we have achieved any check values lesser than 2. There is only one value, that is 1 having value lesser than equal to 2. We need to update this with answer of index 1, that is 1 plus 1, that is 2. Okay. Okay. Okay, let's move. And why we are doing this, for each index till I we have already calculated the answer and we want to calculate answer for j. And for any index I, we already find whatever maximum subsequence we are able to achieve till I, and its length is already calculated. And for each I between 0 and j minus 1, we will find if there is any subsequence having value lesser than a of j, and if we have already calculated its maximum subsequence length, and at last we have value a of I and its value is lesser than a of j, and at last we will add a of j and this maximum length I, and for this we have already find maximum subsequence, and at last we will add jth element, and this is going to be answer of whatever we are able to achieve till I plus 1, that is jth element. We need to calculate this for all I and update the maximum with jth index. So this is the brute force solution for each index j between 0 to n, and I is going to be less. Okay, so for all n we are moving n minus 1. So for all n we are moving n minus 1. So this is going to be O of n square solution. So as per constraint, there is 10 of 4, so O of n square is not going to work. So we need to find some optimal solution. Move to the solution second. Okay, so our what answer is going to be max of answer of I plus 1, where I is between j and condition is a of I is need to be lesser than a of j. So this is the finally we need to achieve it to calculate the answer of I. Okay, so suppose we maintain some seg array. Seg array is like for, for each value 0 to max in the array. So we are going to maintain an array of length max value in the array. So while we are calculating for answer of I at index a of I in set, we will put this answer of I. So while we are calculating answer for each I in seg array at each index 4, these are the values as index, and these are index for answer for I. So for each a of I we are storing corresponding answer. So when we want to calculate answer for j in this seg array, we need to find max of 0 to a of j minus 1, max value, as these are storing indexes. Initially the value is going to be 0. Okay, and these index are values of a of I. While we are calculating answer of I having value a of I, we have put this answer in this array. And for j we need to find all the values before it having value lesser than j. That is for this array having value between 0 to a of aj minus 1, we need to find, we need to take max of this range. I hope this I hope this makes you clear. And initially all these values are 0. If we are going to take max, it's going to return it as 0, and we just need to add 1. That is, we need to add 1, and whatever maximum we are able to achieve is, as the value is going to be returned to 0 plus 1, that what maximum sequence we are able to achieve is of length 1. So this 0 is not going to affect our answer. And for each I we have already put these values in this array. We take the maximum from 0 to a of j minus 1. So all the values which are lying before j having value lesser than a of j, its corresponding answer already placed in this array. And we are going to take maximum of those a of I 0 to a of j minus 1. And for our requirement, we for this equation we want to find maximum answer maximum of answer of I having value lesser than a of j. And all these a of I were already put in this array, and we just need to find a maximum of range between 0 to a of j minus 1. I hope this makes you clear. and this range max can be found using the segment tree. So for segment tree, we find a maximum value 0 to a of j minus 1. I hope this makes you clear. Now I'll move to the code part. So code is purely simple. So this is the segment template I have already explained you. So initially the value is going to be 0, and while building we take out the maximum of both the left and right part, and while updating the same maximum, and while querying for if you go out of range, we are going to return it at 0, as this is not going to affect our answer because maximum of a 0 and any value is going to be that value. And again we take the maximum of both range. Now move to the solution part, and for first we found the maximum of a array, and now we create the segment tree of length x and then build it. And for we need to calculate answer for each index to create this array of length n. And to calculate answer of I, we just query the segment with values between 0 to a of I. Here a of I is already included because value can be lesser than equal to, so we calculate answer to 0. Sorry, I just here I this is not a of 0 minus 1. We can include a of j. Okay. Yes. Okay. So we need to calculate max value 0 to a of I. Okay, and add at 1. At last, we need to update this answer of I in our segment tree at index a of I. That is, at a of I, answer is ans of I, because later we need to take the maximum for calculating answer for next I. Okay, at last we return this answer of I. I hope this makes you clear. If you have any doubt, please leave a comment. Thank you.